Welcome to the video tutorial. This is Unit 2, page 1. It's our first day's assignment. In order to do today's assignment, you're going to need to open the attachment or have your green periodic table that looks like this. This is one where it's labeled, so we have our S block elements, S1, S2, our P block elements, P1, 2, 3, 4, 5, 6, our D block 1 through 10, and our F block 1 through 14. So this is really useful because it reminds us that the order that elements fill up on. So we're going to drive across the period, and that's why I've got my little car here. Okay, we're going to start at the beginning of a period and drive to the end of it. So period 1 doesn't extend over here at all, and sometimes it's helpful to see it. Okay, period 1 ends right there. So we're going to go to element 1, 2, and then we drive to elements 3, 4, and that extends over here, 5, 6, 7, 8, 9, 10. And we come back down and we keep going all the way across as we're going. Okay. So the electron configuration, remember, is just where those electrons are. We learned about energy levels last unit. The first period has 1 energy level. Calcium in the 4th period has 4 energy levels. But this unit we're starting to learn about the sublevels, and that's what the S, P, D, F are all about. So we're going to drive our cars, and we're going to see how we can get on this. Okay. Hydrogens are very, very easiest one. So for electron configuration, hydrogen is where we start. It's our home anyways. So hydrogen, we would just write 1, S1, because that's where we're at if we're reading that graph. So 1, S1. And remember from class that there's no noble gas notation. There's no shortcut for hydrogen. Helium then would be 1, S2. That's where it's at. Lithium ends at 2s1, but we need to write down where we go at the end of the block, remember? So the S block, the end would be S2. The end of the P block is P6. The end of the D block is D10. So we'll come back to lithium. Sometimes I think it's more useful to do a harder one to start with. So let's look at magnesium first. Okay. So if magnesium is where I'm going, and I saw lots of people ripping up little pieces of paper so that they're moving 2 pieces of paper like this, I think that's a good idea to keep track. We start at our home, okay? So this is my home. I'm going to start at hydrogen, and I'm going to drive to the end of the block. And when I get to the end of the block, I'm going to write down where I am. So I'm at 1, S2. So for magnesium, 1, S2. And then after 2, I go down here to 3. I start on the new period, and I drive until I get to the end of the block. 2, S2. Okay, and then I have to keep going along this period because it extends over here. So after 4, I go to element 5, which is over here, and I drive until I get to the end of the block, which will be 2, P6. Now I saw some people writing everything. They were writing 2P1, 2P2, 2P3, 2P4. I just kind of told them, basically all we're saying is, hey, drive to the end of the 2P6 block. And so I know, oh, so I pass P1, P2, P3, P4, P5, P6 on my way. Okay, after element 10, we go to the start of the next period, which is element 11, and I drive to the end of the period, which is also where I'm going, magnesium, 3, S2. So that will be the electron configuration for magnesium. Now let's think about this. Magnesium has 12 as its atomic number, which means it has 12 protons and 12 electrons. So if we count this up, excuse me, I'm going to grab my calculator just so you can watch the math. Okay. All 12 of these are written up here. That's what these little numbers mean. So I've got 2 electrons in my 1s, plus 2 electrons in my 2s, plus 6 electrons in my 2p, plus 2 electrons in my 3s equals 12. So all this is showing me is that's where the 12 are in the ground state, so when it's not excited. All right. Now there is a shortcut called noble gas notation. So for magnesium, you need to do the long electron configuration and the noble gas notation. This is like going from a landmark. So if you want to give directions from school to, I don't know, NRG Stadium, okay, that's going to be a long list of directions. Getting off out of the parking lot and onto the feeder road and onto 45 South. So that's the long directions. Or you can use a shortcut and start from a landmark. So you could say, okay, well, go downtown, and from downtown, you get there this way. And so it kind of shortens directions. So what we use is our noble gases. Remember, these are our noble gases right here. There's one weird thing about this periodic table, that helium is also a noble gas. It's just an S2, so it's over here. I'm going to turn this over so you can see that. that helium is a noble gas. Okay? So I like to say we're using their castles as a shortcut. Remember, nobility is the royalty. So we're using their castles as a shortcut. So instead of saying, from my house, from hydrogen, here's how you get to magnesium, I'm going to say, start at this castle. And the last noble gas that I get through on my way to magnesium was neon. Okay? So I'm going to say, hey, start at neon's castle. Okay? And we'd say, you know how to get there, right? And everyone says, yeah, we know how to get to neon's castle. It's giant. Okay, royalty. So instead of saying all of the directions, I can just start at neon, still trying to get to magnesium, and then I give directions from there. So after neon 10, I go to 11, and I would write 3s2. And there's my shortcut. Because this whole thing right here, 1s2, 2s2, 2p6, that's neon's configuration. So it's just kind of in brackets. By the way, we're starting with neon, and then where we go from there. Okay. Let's do another one of these. Let's do, how about titanium? That one gets a little messy. Titanium's TI, number 22, right here. And let me see if I can get this to work. I'm going to move the camera, so sorry, it's going to be a little shaky here for a second. There we go. Okay. So titanium, number 9, TI. I'm going to put one of my pieces of paper, or in my case the star, where I'm going, and I'm going to start at home for the electron configuration. And I'm going to drive until I get to the end of the block. Okay? So the first thing I do is the 1s2, which means 1s1 and 1s2. And then I go to the start of the next period, and I drive to the end of a block. Okay, remember this is the S block right here. So that's 2s2. And then I keep going along the period until I get to 2p6 at the end of a block. I write down that direction, 2p6. After 10, I go to 11, and I drive to the end of the block, which will be 3s2. I keep going through 3p6. And after 18, I come down here for 19. I drive to the end of the block, which is 4s2. And then I drive either to the end of the block, or in this case, I get to titanium. Titanium is at 3d2. So I would write 3d2. Now, a lot of people freak out that a 4 came before a 3, and that's fine. Geometrically, 4s is closer to the nucleus than 3d is, and so it's lower energy. You don't really have to worry about memorizing the order that it fills up in. In college, you will. But in high school, we give you this periodic table. Just listen to the directions it gives you. It told me that I went to 4s before 3d, and that's just fine. No worries. Okay? So 3d2. Another thing that we can always ask on this is I could say on a test, what element has its last electron in 3d2? And then you just come here and go 3d2, that's titanium. So we're just kind of graphing. 3d6 is iron. 4d9 is silver. Okay? And then our noble gas notation for this one. Titanium has not gotten to krypton yet, but it has passed argon. So I can say, hey, here's the shortcut. Instead of driving from Oak Ridge High School to NRG, we're going to take a shortcut, and we're going to start at argon's castle. So starting at argon. All right, so I'm still going to titanium, but instead of starting here and doing 1s, 2s, blah, 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 we can start at argon, okay, and say, all right, so we started at argon, that's where we're at, and then we're going to come back down here. After argon, I would need to go to 4s2, and then to 3d2, okay, and you know what, I wrote this in the wrong spot. I'm so sorry, I lost track. Okay, this whole thing was titanium, so if you just said that, I apologize. I was trying to keep it on camera, and I was not paying attention to where I was writing. But this answer belongs here on titanium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. Does not belong here for chlorine. Chlorine would have a different one. Okay, the last thing I really want you to pay close attention to is this is something we added this year, because these are questions on your exam that students are doing poorly on, because it's from the notes and they don't really think about it again. So we're trying to do a good job of putting all exam questions in homework. So Heisenberg uncertainty principle, you'll need to check your notes for that. If you were absent, find the hard copy of notes I posted where it says we can't know these two things are mutually exclusive. 3D orbital is a 3D region around the nucleus where an electron is likely to be found what % of a time. Again, that was in our notes. And our current model of the atom is called the blank model. Those are things that we would expect you to have memorized for test day. Okay. Just page 1 was assigned today. For those of you who were here, this was probably a really good quick refresher. For those of you who weren't, this is still probably very confusing. This was probably the most confusing day to try and learn on your own. And I'll be totally honest with you on that. The quantum mechanical model is really, really weird. So you're going to need to come for Eagle's Nest or tutorials as well. But at least you can get a good start on this. All right, y'all. Thank you so much.